Hello students, today we'll discuss 7 to 11 exercise problems of chapter 2 electrostatic potential and capacitance. Let us start. So in seventh problem of exercise we have three capacitors of capacitance 2 picofarad, 3 picofarad, 4 picofarad, and we are told that the three are connected in parallel. The first question is, what is the total capacitance of the parallel combination? And second one is, how much charge is deposited on each one of the three when when the combination is connected to 100-volt supply. So which data we are given? We are told that C1 is 2 picofarad, C2 is 3 picofarad, C3 is 4 picofarad. So are the three capacitors C1, C2, C3. Maybe this is 2, 3 and 4 picofarad, and here is the battery of 100 volt. And how they are connected? They are connected in parallel. It means that individually C1 is having connection with battery, C2 is connected with battery, C3 is also connected with battery directly. So what happens here? When the charges come out from positive terminal and when they reach here junction point or branch point, all the charges have same energy, right? And so the charges going towards C1 or charges going towards C2 or charges going towards C3, they have same energy, and so only we say that in parallel combination potential difference is constant. Means difference of energy of the charges on left side and right side. Whatever is the energy difference for C1, same is the energy difference for C2, and same is the difference of the energy of the charge. If you check in C3, answer remains same. So we say that in case of parallel combination, what is constant? Potential difference across each capacitor is constant. Okay, but what happens here? When the group of charges come from battery and reach the junction point, would they be equally distributed into three groups? No. Why no? Because C1 is smaller capacitor, C3 is the largest one, and so maximum charge will go towards the C3, because it is like C1 is like smaller room and C3 is like bigger room. So if people are coming from somewhere, would the group of people be equally distributed in three rooms? Obviously, smaller room will get less number of people and larger room will have maximum number of people in it. Okay, so that is true with charges also. So when we find out charge, the charge on C1, if it is Q1, it should be least, and charge on C3 should be maximum. Okay. How do we determine total capacitance? Actually, effective capacitance is a more appropriate word. So we know that for parallel combination, the effective capacitance is C is equal to C1 plus C2 plus C3. So do we have C1, C2, C3? Yes, we have 2 picofarad, 3 picofarad, 4 picofarad. So we can find out effective capacitance, that is A, answer of A. Determine charge on each capacitor. So how do we find out charge? So we have formula from definition of capacitance. We know that C is equal to Q by V. So when you are finding out charge on 2 picofarad, C is 2 and V is 100. When you are finding out charge on 3 picofarad, C is 3 picofarad, V is 100 volt. Be careful that this is 2 picofarad, means 2 into 10 raised to minus 12, 3 into 10 raised to minus 12, and 4 into 10 raised to minus 12. Okay, so be careful in units, and you will have charges on individual capacitor. And at the end, you can confirm that Q1 should be smallest and Q3 should be largest. In 8.1, we are given a parallel plate capacitor, and there is air as medium between two plates, and we are given area of the plate 6 into 10 raised to minus 3 meter square. Distance is also available, 3 mm it is, and we are asked to calculate capacitance of the capacitor, and we are told that if this capacitor is connected to 100 volt supply, what is the charge on each plate of the capacitor? Very easy one. Start with the data collection, give proper symbol to the numerical values given. That will help us recalling the formula. So what symbol we should give to this quantity 6 into 10 raised to minus 3? Area, so A. 3 mm is distance, so small d. Okay, and that is 3 into 10 raised to minus 3 meter. It's preferable to convert here itself into standard units. And then we are given voltage also. What we are asked to find out? Calculate the capacitance. So C. And what else? The charge on each plate. So Q. A very easy problem, formula based problem it is. How do we find out C? If we have area and distance, so epsilon 0 A by D. Okay, medium is air, so permittivity of air is nearly epsilon 0. Substitute value and calculate. How do we find out charge? So from definition of capacitance, we know that C is equal to Q by V. Do we have C? From first one we will have C, and V is given 100 volts, so substitute and calculate Q. In ninth one, we are asked to explain what would happen if in the capacitor given in previous exercise problem, a 3 mm thick mica sheet of dielectric constant 6 were inserted between the plates while the voltage supply remained remain connected, or if we disconnect the battery. Very interesting problem. We know that whenever we change medium between the plates, capacitance increases by k times. So whatever is the capacitance earlier, when you change the medium between two plates, if the dielectric constant is 6 and if nothing else is changed, then the new capacitance would be 6 times more. It should be 6 times more. Okay. And but then here question is the battery is connected, and during the connection, when the charge is already there on the plates, if you insert mica sheet, what will happen? So we know what happens with the capacitance, but what will happen to the charge or potential? Let us check. So area and distance, these values are taken from previous problem. K is given. Firstly, we are told that voltage supply is 100 volt, and find out what happens. Secondly, we are told battery is disconnected, means voltage is 0. Okay, but be careful that in this case capacitor is already charged, so you already have Q, some amount of Q on the plates of capacitor. So we know that dielectric constant is epsilon by epsilon 0. Okay, so new permittivity, if you want, you can find out with K epsilon 0. So what do we do here? We know that capacitance without dielectric is epsilon 0 A by D, and when you have some dielectric inserted, capacitance can be given as epsilon A by D or K times epsilon 0 A by D. Okay, that is K times C, you may say. So one more thing, we know that C is equal to Q by V, so keep these equations in mind. And then let us understand the situation first, and then we will think how to explain what happens to the charge or voltage when medium is changed. So here is the capacitor and battery, and how it is connected. Let us assume that left side plate is connected with positive terminal, right side plate is connected with negative terminal, and this is the switch. So the moment you switch on the power, what will happen? Gradually the charges are deposited on both plates of capacitor, isn't it? Let the charge be Q. How do I determine Q? What do I know about this situation? So we know that in this situation, capacitance is epsilon 0 A by D. We have A, we have D. Epsilon 0 is supposed to be known, constant value it is. So C we can calculate. Actually, we already have calculated in previous problem, and Q also we can calculate. Okay. Now, when you change the medium, now we have new medium. What will happen now? As the medium is changed, we know that capacitance is changed by K times. Okay. And what is the effect of this K? Now capacitance becomes K times. So earlier if capacitance is 1 microfarad, now it will be 6 microfarad because dielectric constant of mica is 6. So what is meaning of 6 times more capacitance? its meaning is either the charge value will be 6 times more or potential will be reduced by 6 times. Now in this case, potential remains constant because battery is connected, so V potential remains constant. So what is the effect of this increased capacitance? Charge will be K times more. Okay, so when the battery is connected, you have provision of sending more charge, depositing more charge on plates, and then with increased in capacitance, you will have more charge deposited on the plates. Okay, so if battery is connected and if you insert dielectric material, what will happen? The charge will be increased by K times. Okay, but what if we have the battery not connected, and now if I insert the dielectric material, what will happen now? Now the effect on capacitance is same, it is K times more, but now how do I justify this K? How do I explain what is the effect of K? Because now battery is not there to deposit more charge, then what is the significance of increased C value? So now we can say that if battery is not connected, the potential of the charges will be reduced by K times. Okay, so what happens when you have battery connected and if dielectric material is inserted, charge will be increased by K times, and if battery is not connected, then we can say that potential will be reduced by K times. But in either case, you have capacitance increased by K times. In 10th one, we have a 12 picofarad capacitor connected to 50 volt battery, and we are asked to find out electrostatic energy stored in the capacitor. Very easy problem. C is given 12 into 10 raised to minus 12 farad. Okay, 12 picofarad is 12 into 10 raised to minus 12 farad, and battery is of 50 volt. What you are asked to find out energy. So just find out the formula for energy. We know that energy is half CV square. So substitute values and you will have energy in joule. In last one of exercise, we have a 600 picofarad capacitor which is charged by 200 volt battery supply, and it is then disconnected from the supply and connected to another uncharged capacitor of the same value. How much electrostatic energy is lost in the process? Now this lost is actually not proper word, but let us find out how much is the change in energy. So we have a capacitor and a battery connected, and capacitor is charged with the battery. So if the capacitance is C, battery is of V volt, and let us label it as capacitance capacitor 1. So we know that when battery is connected, at that time C1 is Q by V and energy is half C1 V square. So we can find out initial energy. Okay, and there should be some value of initial energy because your charge deposited, battery connected. So you have two ways of finding out energy. One is half CV square you can use, or else you can use Q square by 2C. Okay, now we are told that now disconnect the battery, and then you have charge here. Okay, and you connect another capacitor of same value in parallel. Now what will happen? See, initially consider there is a room, and say 20 people are sitting in a room. Okay, and they have their own comfort level. Now you are giving them choice that there is one more vacant room besides this one, and you are free to go. So what will happen? If both rooms are identical, out of 20, 10 people would go here, 10 will be here. But after the redistribution, the comfort level of the people will be more, and more the comfort level, less the potential energy. Okay, so earlier whatever is the energy, potential energy here, after connecting another capacitor in parallel, the potential energy of this charge will be reduced. Okay, and that is true here also. So how much is the new potential energy here? Now see, charge is being half when you connect another capacitor parallel, and if both capacitors are identical, let us label it as 2, then earlier if charge here is q, now charge on first one is q by 2, charge on second one is q by 2. Does it mean energy will be half? No, it means that energy will be 4 times less, because look at the relation. Energy is proportional to q square. Now you cannot use this formula, 1 half q square we cannot use. Why we cannot use? Because battery is not connected. So now if I am asked to find out energy of first capacitor, which formula I will have to use? Q square by 2c. Okay, so from first situation I will find out q, and in new situation I will take charge to be half, and then I will use this formula, and then the formula tells that the energy should be 4 times less. Okay, so what is the new situation? In new situation, energy, if it is E1, then it is Q1 square by 2C1. And what is Q1? New charge on first one is half of whatever was the charge earlier, because half charge has gone to second capacitor. And then I realized that the energy is 4 times less than the previous energy. Okay, so earlier if it is 100 microjoule, how much is the energy after this connection? It will be 250 microjoule. Okay, but then the second capacitor is also having charge, so it should also have its own energy. So how much is the energy of second capacitor? So we can apply similar logic. How much is the charge here? Half charge is on first one, and remaining half is on second one, and then the energy is E by 2. So earlier, if E is 1000 microjoule, the energy after this parallel combination with first one is 250 microjoule, energy here is 250 microjoule. So what is 250 plus 250? 500 microjoule. Okay, so the new energy of the system is half of whatever was the value earlier with single capacitor. So we can say that earlier, if energy is 1000 microjoule, after parallel combination, energy of the system becomes 500 microjoule. Okay, so the difference of energy is E by 2. And does it mean that the energy is lost? Actually, that is not fair if we say that energy is lost. E by 2 is the new amount of energy required to deposit Q amount of charge on this combination. If you want to accommodate Q charge on first capacitor, you will have to do more work. Okay, because there is single capacitor, and if you have to deposit same amount of charge for in the combination where you have more space, more room, then obviously you will have to do less work. How much less work? Half of the previous value. So that is what it means, and that is all about the numerical. Thank you. Take care.